Click the bell icon to get latest videos from Ekeeda.
Hello friends, let's start with the next question. In the last question, we have seen a grammar which was generating positive closure of the famous language ASB or AB. That particular grammar was not LLK for any value of k. Over here, we are supposed to find some grammar which is equivalent to that. Means over here, we are supposed to find a grammar which was equivalent to that particular grammar. That means it is a positive closure of the famous language and it is LLK as well. Let's start with the question. You will see that the real problem is with the production S produces SS. Without that, just ASB or AB was already LL2. If we replace that production with something else, which is again going to produce some positive closure, we can say that this particular grammar is some value LLK possible. Over here, I am writing the positive closure in a new way. I am writing ASBS. What this will allow? This will allow AB in one or more number of time. Basically, it is a positive closure. And whenever I have to terminate, I have to get the smallest string. Over here, the smallest string is AB. For that, I need to have an epsilon transition. That means S can produce epsilon. Let us see whether this grammar is producing the string which we produced earlier, that is ABAB. We construct the parse tree starting with S. If we just use one look ahead symbol, the first symbol to be generated is A over here. But if we need A from S, which production to be used? Can we use the first one? Yes, because it produces A. Can we use the second one? We cannot, because it produces epsilon. So we can decide between the production using just one symbol. Again, let us see the next production to be used. We are starting from the look ahead symbol B now. We have already generated A over here. Which production to be used with this S to make sure that we have produced a B after the first A? If we use the first production, then we will be generating AA, which is not required. If we use the second production, that is S produces epsilon, you will see that we will be generating A followed by B. And hence again using one symbol, we are able to decide whether to use the first production or the second production. Next, we need to generate second AB pair. Using this A, we need to generate one A because we have generated AB portion already. Look ahead would be now A over here. This S has to be replaced. We can use only the first production, not the second production, because second would lead to an epsilon, but we need A, we use the first production. Again, in the similar pattern, you will see that we need to replace both the S with epsilon looking ahead the symbol. And finally, we can see that the string which is derived is ABAB. This grammar is actually LL1 because using just one symbol, we can decide whether to use the first production or to use the second production. But one question is that, is this grammar actually equivalent to the required grammar? Not really. You will see that this grammar is generating epsilon. Let us say the first grammar that we discussed is G and this grammar is G dash. Let us say the language generated are L and L dash respectively. You will see that L dash is generating entire L but one more string, that is epsilon. We can fix this using a new grammar. Let us say the grammar we are generating is G1. Let us say the new start symbol is S0. You will see that this new grammar is generating exactly the language L, not G dash. Therefore, we have generated an equivalent grammar to the grammar G, which is actually LL. From the coming videos, we will be discussing various properties of context-free languages such as closure property, decidability properties, which we had discussed already about regular languages. Thank you for watching this video. Stay tuned to Ekeeda and do subscribe.